We are made of star stuff. It's a beautiful and profound thought, isn't it? The idea that the very atoms in our bodies were forged in the hearts of ancient stars connects us to the cosmos in a deeply intimate way. This simple statement encapsulates the essence of science, the pursuit of understanding the universe and our place in it. It drives us to look beyond our immediate surroundings and seek answers to the grandest questions. But how do we go from star stuff to unraveling the mysteries of the cosmos? How do we transform our curiosity into knowledge that can change the world? This is where the philosophy of science comes in, a field that grapples with the very nature of scientific knowledge and the methods we use to acquire it. It challenges us to think critically about the processes and principles that underpin scientific discovery. The philosophy of science, in its purest form, is the pursuit of understanding how science works. It delves into the foundations of scientific theories, the structure of scientific explanations, and the criteria for scientific evidence. It's about asking those big, fundamental questions. What makes something scientific? What distinguishes science from other forms of knowledge and belief? How do we know what we know? How can we be sure that our scientific theories accurately reflect reality? These questions are at the heart of the philosophy of science. It's a journey into the heart of scientific inquiry, exploring the assumptions, methods, and implications of our quest for knowledge. It examines the logical structure of scientific theories and the role of experimentation in validating them. The philosophy of science is not just an abstract intellectual exercise. It has a direct impact on how we conduct scientific research and interpret its findings. It influences the way we design experiments, analyze data, and draw conclusions. By understanding the strengths and limitations of our scientific methods, we can ensure that our pursuit of knowledge is both rigorous and meaningful. It helps us to avoid the pitfalls of bias and error, and to build a more accurate and comprehensive understanding of the world around us. As we embark on this journey, we will explore the rich history of scientific thought, the groundbreaking discoveries that have shaped our understanding, and the ongoing debates that continue to drive scientific progress. Together, we will delve into the fascinating world of the philosophy of science, uncovering the principles that guide our quest for knowledge and the profound impact they have on our lives. Our journey begins here with a single, profound thought. We are made of star stuff, and from this thought, we will explore the vast and wondrous universe of scientific inquiry, seeking to understand our place in the cosmos and the nature of the knowledge we pursue. At the heart of science lies a powerful tool, a systematic approach to unraveling the mysteries of the natural world, the scientific method. It's a beacon of rationality, a way of thinking that has revolutionized our understanding of the universe. But what exactly is the scientific method, and why is it so crucial to the philosophy of science? The scientific method is not a rigid set of rules, but rather a flexible framework that guides scientific inquiry. It's a process of asking questions, making observations, formulating hypotheses, testing those hypotheses through experiments, and then analyzing the results to draw conclusions. This iterative process allows scientists to build upon previous knowledge and refine our understanding of the world around us. The beauty of the scientific method lies in its objectivity. It's not about opinions or beliefs, it's about evidence. By grounding our understanding of the world in empirical observations and testable hypotheses, we move away from speculation and superstition towards a more reliable and verifiable understanding of the universe. Every scientific endeavor, every groundbreaking discovery, begins with a simple but profound act: observation. It's the cornerstone of all scientific inquiry, the very foundation upon which we build our understanding of the universe. It's the spark that ignites our curiosity, the initial flicker that sets our minds ablaze with questions and possibilities. This spark is the fuel that drives our quest for knowledge, pushing us to explore, to experiment, and to seek answers to the mysteries that surround us. Whether we're gazing at the stars in the night sky, marveling at the vastness of the cosmos and pondering our place within it, or peering through a microscope at the intricate workings of a cell, uncovering the hidden mechanisms of life itself, observation is the first step on our scientific journey. It's the act of noticing, of paying attention, of being present in the moment and truly seeing what is before us. Observation is more than just passively seeing. It's about actively engaging with the world around us. It's about noticing patterns, asking questions, and seeking to understand the why and how behind the what. It's a dynamic process that involves both our senses and our intellect. Why is the sky blue? How do birds fly? These questions, born from simple observations, have driven scientific inquiry for centuries. They compel us to delve deeper, to experiment, to hypothesize, and to seek out the underlying principles that govern our world. Why is the sky blue? How do birds fly? These seemingly simple questions, sparked by observation, have led to some of the most profound scientific discoveries in human history. They have opened up new fields of study, revolutionized our understanding, and transformed our world. From the theories of relativity to the discovery of DNA, observation has been the starting point for countless breakthroughs. It's the thread that weaves through the tapestry of scientific progress, connecting the past with the present and the future. But observation is not without its challenges. The path of discovery is often fraught with obstacles and setbacks. Our senses, while remarkable, are not perfect. Our senses, while remarkable, are not perfect. We can be deceived by optical illusions, misled by our own biases, and limited by the capabilities of our instruments. We can be fooled by illusions, biased by our preconceptions, and limited by the sensitivity of our instruments. These limitations can obscure the truth and lead us astray, and limited by the sensitivity of our instruments. Therefore, it's crucial to approach observation with a critical eye, to question our assumptions, and to seek out new methods and technologies that can enhance our ability to see and understand. Therefore, it's crucial to approach observation with a critical eye, to be aware of our own biases, and to constantly seek new and improved ways of observing the world around us. This means being open to new ideas, embracing uncertainty, and being willing to revise our understanding in light of new evidence. To be aware of our own biases, and to constantly seek new and improved ways of observing the world around us. It's a continuous process of learning and adaptation, of refining our techniques and expanding our horizons, and to constantly seek new and improved ways of observing the world around us. In this way, observation remains at the heart of scientific discovery, guiding us as we explore the unknown and uncover the secrets of the universe. Observation may spark our curiosity, but it's the formulation of a hypothesis that truly sets the scientific process in motion. It's the moment when a scientist moves from merely noticing the world to actively questioning it, seeking to understand the underlying principles that govern the phenomena they observe. A hypothesis is an educated guess, a tentative explanation for an observed phenomenon. It's a statement that can be tested and measured, providing a foundation upon which further investigation can be built. This educated guess is not pulled out of thin air. It is grounded in existing knowledge and previous research, making it a logical step forward in the quest for understanding. It's a leap into the unknown, guided by our current understanding of the world, but always open to revision in the face of new evidence. This leap is both thrilling and daunting, as it requires a willingness to venture beyond the boundaries of current knowledge and to embrace the possibility of being wrong. Crafting a good hypothesis is both an art and a science. It involves a delicate balance between creativity and logic, intuition and evidence. A well-crafted hypothesis can open new avenues of inquiry and lead to groundbreaking discoveries, while a poorly formulated one can lead to dead ends and frustration. It requires creativity and imagination, the ability to see connections where others might not. This creative aspect of hypothesis formulation is what allows scientists to think outside the box, to propose explanations that are not immediately obvious, but that can lead to significant advancements in knowledge. But it also demands rigor and precision. A hypothesis must be clearly defined and specific, so that it can be tested through controlled experiments and observations. This precision ensures that the results of the tests are meaningful and can be used to draw valid conclusions. A hypothesis must be testable, meaning that it must be formulated in a way that allows us to collect evidence that either supports or refutes it. This testability is what makes a hypothesis scientific, as it allows for empirical investigation and validation. The beauty of a hypothesis lies in its vulnerability. It is a proposition that is open to scrutiny and challenge, and it is this openness that drives scientific progress. By subjecting hypotheses to rigorous testing, scientists can refine their understanding of the world and build a more accurate and comprehensive body of knowledge. It's not a sacred belief or an unquestionable dogma. It's a proposition put forward to be challenged, refined, or even discarded based on the evidence. This willingness to question and revise hypotheses is what allows science to self-correct and evolve over time, leading to a deeper and more nuanced understanding of the natural world. This willingness to embrace uncertainty, to let go of cherished ideas in the face of contradictory data, is what sets science apart from other ways of knowing. It is a testament to the humility and open-mindedness that are at the heart of the scientific endeavor, and it is this spirit of inquiry and discovery that continues to drive the advancement of human knowledge.